All right, in this video, we are going to be talking about our powers of 10 math, which is just a fancy word for saying common base math. But a lot of what we will deal with in electronics is going to have a value to some power of 10 that we can then easily manipulate and take it into a different form to solve one way or the other. So with that, we're going to be talking about the different ways that we will do powers of 10 math to kind of simplify things, make things easier for us. And then we're also going to talk about roots. Now, roots can be kind of a complicated topic, but with hopefully after this explanation, it'll be a lot easier to understand. So the first things that we're going to look at is when we come into a power of 10, we need to know how to manipulate it. So when we're dealing with powers of 10, so that's going to be a base 10 to some power. Okay, this is what we mean by a power of 10. A 10 raised to some power of some value of some sort. And we'll talk about those a little bit more when we get going. So the first thing we're going to look at is when we multiply. So multiply or when we divide. So anytime we're dealing with a multiplication or a division of powers of 10, we can make these easier. The way we do that is we look at our numbers. So if we have 10 to the third times 10 to the second, I need to be able to solve what that is. Now again, when we're dealing with powers of 10, we're assuming that we all have the same base 10. But again, this works for any combination where you have the same base. So this is our base, this is our exponent, or our power. Okay, so what we do is when we're multiplying or dividing, we take whatever base that we started with that we're multiplying together and carry it across. So because we're dealing with base 10, our answer is going to be in base 10. And then when we multiply these powers with the same base, these powers of 10 with the same base, or any other number, like I said, for example, we then take these powers and then we add them together. So this becomes 10 to the 3 plus 2 power, which then can be simplified down to the 10 to the 5th power. If I have 10 to the minus third times 10 to the third, I'm going to multiply, when I multiply these together, I have my common base, so that's going to carry over. So that 10 right there is going to be brought over to here. And then I'm going to have a minus 3 plus 3, which then gives me 10 to the 0 power, which 10 to the 0 power, we know anything to the 0th power is 1. So we're actually going to see this a lot when we get into electronics. We're going to see these powers cancel out, and when we're doing some of the calculations with Ohm's law, especially later on the semester, we're going to see this kind of pattern evolve and become more commonplace than what we're using it for. So then as we keep going, so that's our multiplication. And it doesn't matter if these are positive or negative. We are just going to take the values and we're going to add them together. Now in this case, if I had 10 to the third times 10 to the negative third, again, it doesn't matter. I end up with 10 to the third plus a negative 3, which then still comes out to be 10 to the 0, which again is equal to 1. So then after we go through with those, that makes division just as simple. Division is the opposite of multiplication. And one of the things that we're also going to learn throughout the semester is what the opposite of every functions are. So like multiplication, the opposite function is division. Division, it's multiplication. Addition is subtraction. So we're going to go through all these different ways that we can be able to move these values around and manipulate them and make them easier to solve. So when we come into division, if we have these same values, if I have 10 to the third and I'm going to divide it by 10 to the second, again, I keep my common base, which is 10. So that's going to be brought over. But this time, when I divide, I'm going to subtract my powers. So 3 minus 2. Now again, one thing to keep in mind is we got to keep order of operations and work left to right. So in this case, it's 3 minus 2, not 2 minus 3. So left to right. So then what we end up with is 10 to the first, and that is our final answer. If we have 10 to the minus third divided by 10 to the third, so kind of keeping with our numbers over here, that 10 is going to stay, and I'm going to have a minus 3 because I'm dividing this second part. So that's actually going to give me 10 to the minus 6. I'm making this number more and more negative, which was what happens when we're dividing. We're making it smaller and smaller and smaller. So therefore our power has to change with that relationship. And again, left to right when we order out these guys for our subtraction. And the last example, if I have 10 to the third divided by 10 to the negative third, that's going to be 10 to the 3 minus a negative third. When we have a negative minus a negative, that becomes a positive. So I get 10 to the third plus 3, and that makes it 10 to the sixth. So we do have to be careful when we're going through and solving these values, but what we're after is in the end is we're going to end up with these nice, neat values of 10, which then hopefully later on in our process, we're going to get to the point where these then start falling out the way that we've kind of saw them here with the third to the negative third. We should start seeing that happening a little bit more, especially once we get into the actual electronics theory. All right, so that's our multiply and divide. So now, after that, what we're going to look at is if this, lets me, there we go. Had to hit the right button to get it to scroll. So that's multiplication and division with powers of 10. The next one we're going to look at is add or subtract. So addition and subtraction. So what happens with that? The first thing we need to do is we have to get the values. So get values to same power of 10. Then, once we have things to the same power of 10, then we can come through and do the indicated operation. So then do indicated operation, meaning addition or subtraction of those values. So the way that we do that is we have to look at a few things. So first, if I have the numbers 1.625 times 10 to the third, and I want to add that to 0.004 times 10 to the sixth, then what I have to do is follow my rules. So the first thing is I have to get my values to the same power of 10. Now think of these each individually as its own value, okay? So we've got a value that goes 10 to the third, we've got a value that goes 10 to the sixth. So we've got to get these so those powers match each other. Because right now, 10 to the third does not equal 10 to the sixth. Now we can choose. We can go either direction. We can make the 3 become a 6, or we can make the 6 become a 3. It doesn't really matter as long as we follow these rules. So in this case, I'm going to take this value, the 6, and I'm going to convert it into a 3. So this one I need to change until it becomes times 10 to the third. Well, how do I do that? Well, the first thing we're going to look at is where our values and our decimal points are, and how do I need to get them to that point. So here, I need to make my 6 turn into a 3. So am I going to make my 6 bigger, or am I going to make my 6 smaller? The answer is smaller. So I need to make my 6 and decrease it. So that power of 10 is going to decrease. To keep this part of the equation equal, if I decrease my exponent, I have to increase my value or my number, okay, without the power of 10. So if this number here gets smaller, this number here has to get bigger to keep things balanced and even. Now, one of the cool tricks that we have is when we are using powers of 10, that gets into our decimal format, our decimal number system. And this makes this a whole lot easier than if we had it in a different base. So here, we come back, we're taking our exponent, we're decreasing it 3. So we're making it 3 steps or 3 times smaller in its magnitude. So therefore, I have to make my number 3 steps bigger to balance it out. So 3 steps smaller is my exponent. And I have to do 3 steps bigger for my value or the number. Okay? And in base 10, it's really easy. All we have to do is move our decimal point a little bit. So in this case, I have 0.004. Because I moved it a power of 10, I can do this trick. So to make this number bigger, I have to move this over 1, 2, 3 times. So 1, 2, 3 jumps. Keep everything equal. So then what I have now is 0.004 times 10 to the 6th. That then becomes 4 times 10 to the 3rd. And now I have got my common base, 10 to the 3rd and 10 to the 3rd for those units. So that's step 1, is get them into the same power. And with base 10, it's really easy. You just go up and down your decimal, you make your number bigger or smaller. You do the opposite to keep the balance in your exponent. So now my numbers are going to translate. So this whole value is then going to come down here. I've got 1.625 times 10 to the 3rd, and I'm going to add my newly converted value, which is 4 times 10 to the 3rd, and then I perform the indicated operation. Now here's one of the little secrets and tricks that we can do. We have the same power. We are adding these values together, which means that is going to stay the same. So this is 10 to the 3rd, this is 10 to the 3rd. These are the same. That is then going to translate over here to my answer being 10 to the 3rd, at least to start with. Okay, depending on later on, we might change it into a different format. But either way, that is going to stay the same. So now that I just have left, so this is gone, the 10 to the 3rd, the 10 to the 3rd, when we're adding, those basically cancel each other out and merge together to form in to a 10 to the 3rd. And then I just have to do my addition with what's left. So I have a 1.625 plus 4 times this 10 to the 3rd value, which then that gives me 5.625 times 10 to the 3rd. Another way to look at that is when we run through this is all I did with that 10 is I applied the distributive property. I factored out that 10 to the 3rd to be able to pull it off to the other side just to manipulate the values that are left. And we'll talk about factoring later, but that's basically what I did, is I factored out the 10 to the 3rd, put it on my answer, and then combined everything else together. So mathematically, that's how it worked. The shortcut really is just thinking about it. If I'm adding two numbers, they have the same power, that same power is going to carry over to my answer. It's really just quite as simple as that. So subtraction is going to work the same way. If I have my 1.625 times 10 to the 3rd, and I'm going to subtract the 0.007 times 10 to the 5th, well, same process. I've got to get these guys down to the same power. So here I can take my 3 and make it up to a 5, or I can take my 5 power and take it down to a 3. Honestly, in this case, again, I'm going to go after this one and make it smaller, or make the power smaller, bring this number bigger, and then I can perform the operation. So, converting this guy, I'm going from a 5 down to a 3, meaning I'm going to go down, so a minus 2 steps. Okay? That means I'm getting smaller up here, so this has to get bigger by 2 steps. So 0.007, and I go bigger by 2 steps, 1, 2. That gives me a 0.7 times 10 to the 3rd. So then I can come back over here, bring my number down that I didn't have to mess with, 6.25 times 10 to the 3rd. Again, dealing with 10 to the 3rd, 10 to the 3rd, That's going to carry over, distribute it out, factor it out, however you want to think about it. And then I just perform my operation. 1.625 minus 0.7. Now, the last part, times 10 to the third, we carry out that operation. So I'm going to get 0.925 times 10 to the third. And that is my answer for this equation. Now, one of the things we want to be careful for and looking at, as we're going to talk about later on, is we may want the answer in a certain format and a certain unit, things like that. If it doesn't tell you one way or the other, you are just going to leave it in the units that you ended up with. Most of the time, however, the answers will ask you to put things into scientific or into engineering notation. And again, we will talk about those when we get there. But the idea is put your answers in the values that you ended up with and then convert it to the answer, or to the value, or the units that the answer wants it in. And those will all be displayed in the different screens. So that's really the trickiest part with the powers of 10 in this aspect, is the addition and the subtraction. So again, step one, we have to convert things to the same power of 10, and we just pick one and arbitrarily decide, it doesn't matter which way you go, and then perform the indicated operation. All right, one last section that we want to cover for our powers of 10 is when we raise a power to a power. So for example, if I have 10 to the 5th, and I'm going to raise that whole value to the 7th power, what that really meaning, again, is 10 to the 5th times 10 to the 5th times 10 to the 5th times 10 to the 5th, not 15th. Here we go. 5th times 10 to the 5th. 1, 2, 3, 4, 5, 6 to the 5th, and my 7th 10 to the 5th. All right, so that's the same thing as what we're doing. We're just representing it two different ways. So the way that we do this part is we take our base value and our base value inside our base power inside the parenthesis, which in this case is 5, and then we are going to multiply it by whatever power we're raising it to. So now this becomes 10 to the 5 times 7, which is 10 to the 35th. If we look at it in this format, we can apply the same rules. We just would have 10 to the 5 plus 5 plus 5 plus 5 plus 5, 2, 3, 4, 5, 6, and 7. So it's just a combination of what we've already done. We're multiplying a power by a power. They're all base 10, and the power is 5. We just add them up together. 5 plus 5, 7 times, or we just multiply it. Okay, so this gets us into the next part. This part is pretty easy. So we've got basically our multiplication here. We're adding it. But we also can have ways where we're going to end up dividing these powers and making them smaller. One of the aspects that we're going to look at with that is roots, square roots, cube roots, all those types of things. Now, when we first get in looking with roots and powers of 10, they can be kind of scary. So if I take the square root of 10, what that is going to express to as far as numerics go is a square root or cubic root or whatever it is just simply a fractional power. So 10 to the square root is simply 10 to the 1/2 power. And now all of a sudden, once we have this converted into a number, it's really easy to figure these out. We can apply all these other rules to it. So just like if I had the square root of 10 raised to the 4th power, okay? Internally, I'm going to convert inside my parentheses to 10 to the 1/2 power to the 4th power, which then that translates 10 to the 1/2 times 4 as far as my power goes. So then I'm left with 10 to the 4 over 2, or 10 squared. So now all of a sudden these roots are just a number. We can easily solve for them and we can easily put them in any of these other equations. Well, now what happens if we had a cube root? Cube roots are even funner than square roots, okay? Same rules apply. If we have a cube root, it becomes 10 to the 1/3 power. The fourth root of 10 is 10 to the 1/4 power. And like I said before, now it just becomes a number. We don't have symbols, we don't have nothing, and cube roots can become just another thing that we deal with. Now it becomes easy to solve the 173rd root of 1,000, for example. That just simply becomes 1,000 to the 1/173 power. Really easy. So we have ways of making our powers bigger, powers to a power. We can multiply them together, we can add them together, whatever. And then we can also take powers, or the bases to a fractional power, which is just a cube root. And going back and forth. If I had a number that said x to the 1/5 power, that's the same as saying the 5th root of x. And then we can really quickly, easily punch these into our calculator, even if our calculator doesn't have a function to give us a different root of a value. Makes it really easy to then punch them into the calculator, and we don't have to have an expensive calculator to do these types of problems. And again, anytime that we have these roots, they can be applied through any of the formulas or any of the theorems that we have for powers of 10, multiplying, subtraction, dividing, that kind of stuff.